So law of sines is one of those things that you're going to look at and you're going to be like, why didn't they teach us this a while ago? Because anytime we dealt with triangles, you remember geometry? When we solved for triangles, they always had to be right triangles because you always had to, sine was opposite over hypotenuse. You had to have a hypotenuse, had to be a right triangle. The law of sines lets us solve for many, many, many more different types of triangles. In fact, it works for most oblique triangles if we know, in fact, it works for all oblique triangles if we know a couple key pieces of facts. And particularly, if you have any triangle and you know two angles and a side, you can use the law of sines to find all the other information. Doesn't have to be a right triangle. There's no hypotenuse or anything. All we need to know are two angles and a side. It's a good thing to look back, not so much on this, but just remember when we talked about like angle, side, angle in geometry, and angle, angle, side. It talks order matters in how you describe these things. So this one's angle, side, angle, because the two angles kind of make the bread of the sandwich of the side. The side is included, it's between them. That's what makes it angle, side, angle. For angle, angle, side, you just need two angles and a side that's not between them. So this could have been the bottom side as well. Not terribly important to know for law of sines because we just need to know two angles and a side and we can use it. But when we get to the law of cosine and when we talk about another aspect of law of sines on Monday, it's a good thing to get back in the habit of being able to look at what's given to me and be able to label what type of information I was given to me. Whether it be angle, side, 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 angle, which is a bad one. We'll talk about that on Monday. Or angle, angle, side. All right, so it's just important that we can label these in our head when we're given the information. So down below is actually our law of sines. Our law of sines boils down to sine alpha, so the sine of an angle divided by its side opposite equals the sine of another angle divided by the side opposite, which is equal to that third angle divided by the side opposite of that one. It's a very powerful tool, and you'll see today it's pretty easy to use to solve an entire triangle. However, I'm going to rearrange this just a little bit. I'm going to rearrange it just a little bit. We are going to flip everything. Rather than doing sine alpha over A, we're going to do side A divided by the sine of angle A equals B over the sine of angle B equals C over the sine of C. And why I did that is because this method is set up to find a missing side. The one that I provided to you in that square is the traditional law of sines, but it is set up to really find angles. And since with law of sines, most of the time I'm given two angles, to find that third angle, it'd be pretty ridiculous to use the law of sines because every triangle is 180 degrees. If I know two of the angles, I'd much rather in my head go 180 minus that angle gives me my third angle rather than plugging stuff into a big clunky formula. All right, so we're going to primarily use this bottom one because we're looking for sides today. All right, let's go ahead and just go into it. We don't have a ton of time to dilly-dally. All right, so we have to solve triangle ABC where B equals 34 degrees, C equals 64 degrees, and A equals 5.3. So I do have two angles and a side. Automatically means I can use the law of sines. My hint to you is always draw the triangle. It makes your life so much easier. And it does not need to be an accurate representation of your triangle. Almost every time you'll see in my class today and Monday and Tuesday, I draw the same triangle every single time, no matter what degrees they give me. And I'm going to go ahead and label this A, B, C. So the side opposite angle A, I'm going to list as lowercase a. The one across from angle B is lowercase b. The one across from C, although it looks the same, is a lowercase c. It's hard to have a lower and uppercase C. And we'll see on the third problem how mathematicians have dealt with that. All right, so we'll just list the information that was given to us. So it says B is 34 degrees, so let's go ahead and put 34 degrees in. It also says that C is 64 degrees. And it says angle, or side A equals 5.3. So in fact, we have angle, side, angle, because that side is sandwiched between those two angles, so I can definitely use the law of sines here. All right, let's go ahead and find angle A. It's always the easiest one. If they give me two, we find the third one. So I do 34 plus 64 equals 98. 98 plus 82 gives me 180 degrees. So in fact, this angle here, maybe I'll do it in red because I'm just doing it now, is 82 degrees. Like I said, that's the easiest thing to find first. Even if you have no idea how to do the rest of the problem, at least I can give you a point because you knew something. All right, and I'm going to list it down here that A equals 82 degrees, because that's the one I found. All right, now we're going to use the formula from the other side, the one that readjusted. So the first thing I want to find is which one of these do I know the side and the angle opposite? Well, I only know one side is 5.3, so hopefully I know the angle opposite. I do. This is going to be the key to finding all the other ones. So we always start with the side I know that has the opposite angle that I know. And so we're going to list that as A divided by sine of A. And using our formula from the other side, that's going to be equal to, let's go ahead and find side B. Doesn't matter which one we find first, but I'm going to find side B. And that's over sine of angle B. Now we just fill in the information that we have. Side A is 5.3. Sine of A, so we have sine of angle A. Angle A was 82 degrees. And that's going to equal, I don't know what side B equals, it's just a blank right there. So we'll say B over sine of, I have the angle of B though, and that is 34 degrees. I need to have B equals some number. I need B equals some number, so I need to multiply both sides by sine of 34 degrees. I'm going to shift this over just so I can show it, just for people that aren't sure what I'm doing. I am straight up going, I'm going to multiply this side by sine of 34 degrees so that this cancels out. And multiply the other side by sine of 34 degrees. And that's going to give me B equals sine of 34 degrees times 5.3 over sine of 82 degrees. All right, so now we'll take out our formula sheets, and we can use half angles and double angles to put this, because 34 degrees isn't on our unit circle, right? So we're probably going to use a half or a double angle in order to, I'm just kidding, we're just going to use our calculators.
You really got me.
We're just going to use our calculators.
I was just like, are you
We're just going to plug this in our calculators, but we're going to make sure our calculator is in what mode?
Degree.
Degree mode. So go ahead and plug that in. You should get out, I don't even have my sheet anywhere near me. You should get some number that rhymes with 3 or 4, I think. 3.
What?
You should get 3 out when you plug this in your calculator.
Oh, I totally did that.
Nice. Make sure you can plug in your calculator. Don't take my word for it. You don't want to learn how to use your calculator on the day you take a test. If you're not getting the right answer, please let me know.
That should be like 2.99, right?
Yeah, 2.99 is about 3. What'd you get, Mara?
I got 3.06.
I think, what did it come out to?
2.99.
Yeah, I think it was 2.99. You were close. We'll try the next one. Try the next one. Because we still are missing an angle, or a side. I still have to find side C. Well, finding side C is the exact same strategy. Take what was given to you in the beginning, A divided by sine A, make it equal to C over sine of C, and fill in that given information. So our A is 5.3 divided by sine of exactly the same, 82 degrees. That's going to equal C over sine of angle C. Angle C is 64 degrees, which means that C is going to equal sine of 64 degrees times 5.3 over sine of 82 degrees. So C is going to be about, we'll go with 4.8, about 4.8. Okay, we got time. Work out? That's it. These are all the steps to this type of problem. If you're given two angles and a side, this is what we're going to do every single time. We're going to find the side and the angle that we know and set it equal to the side that I'm missing along with the angle. So let's go ahead and do this one more time. And I'll just read the third one's really just to show you a bit of information. So we have to solve triangle ABC. So right off the bat, I'm thinking, well, I have two angles and a side, so I should be able to use law of sines. Let's draw it. Now some people are going to freak out at this drawing, and I'll tell you why. So it says side A is 422, this would be side B, this would be side C. It says that angle A is 30 degrees. And side C is 110 degrees. Does that look like a 110 degree angle?
Yes.
No, not at all.
No, 110 degree angle would be really big. Do I really want on a test take the time to draw the perfect triangle that matches everything? No, this is just to give you an idea of what information is missing. I'm not looking for a perfect drawing of the perfect triangle, the perfect angles where you take your protractor out and you measure it perfectly. Make a crap drawing, so then you know what you're missing and what sides you have. All right, so that's two angles and a side. The other one was angle, side, angle. This one's actually angle, angle, side. Not terribly important, but it's good to get in that practice right now, labeling our triangles what they are. So that is angle, angle, side. So I can definitely use the law of sines. I just have to find that missing angle. This one's nice because it's 110 plus 30 equals 140. B must be 40 degrees.
We would still solve it the same way we did with the last one. Right?
Hey, it's going to be the exact same. All of these, if you're given two angles and a side, they're all going to be the same as what we did above. So that means that B equals that 40 degrees. And now I just got to find the missing sides. So we just figure out the side that I know and make sure it's opposite an angle I know. I know side A, I know angle A. So we're going to say A divided by sine A equals any other side that I'm missing. So let's go ahead and find B over sine B. Side A is 422. Sine of angle A is 30 degrees, equals B over sine of angle B. Angle B is in fact 40 degrees. Multiply both sides by sine of 40 degrees, and you're going to get B equals sine of 40 degrees times 422 over sine of 30 degrees. And is anyone ahead of me and has this? It's a big number.
452.5.
452.5. I was going to say this to 5. Yeah,
540.
Yeah, 542.
542.5.
I was like,
Gotcha. Yep, 542.5. If you got the old calculator out. If you're really good at law of sines, a lot of times you can just skip to this step. Because all it is side B times sine of angle B of the side and angle that you know. So sometimes on my answer key I just skip to this step. Just so you're aware. Alright, but I'm not going to skip it in the notes. I'm going to say, once again, take the side and angle that I know, set it equal to the side that I'm missing, and hopefully I know that angle as well. That's why we need to know two angles. If you don't know two angles, you can't use this. Alright, you have to know two angles. Not side A, sine C. A, once again, is 422 over sine of 30 degrees. Is going to be equal to side C. If I knew it, I could fill it in there, but I don't. And it's going to be 110 degrees. Once again, we're going to have C equals the sine of C times basically side A, 422 over sine A, which is sine of 30 degrees. Charlie, did you have the answer? Is that why your calculator was in the air?
yeah, 793.1.
793.1. Now might be a quick time just to double check if these numbers make sense. Because if this was 542 and this was 1 and this was 3, you know you did something wrong, right? But all these numbers seem to be in the realm of each other. All right, make sure you do that check. Some people I'll give like a side of 10, and then all of a sudden they'll come up with side A equals 1,363, and it's like, no. Double check, because you could be in radians, you might have just missed a keystroke. Instead of a decimal, you put 100 and, I don't know, maybe put in 442.2. Okay, so just check to make sure your answers are in the realm of possibilities. We are not actually going to go through this last one. A, we don't have the time. B, it wasn't why I put it there. This is just to show you another way that the book and a lot of people label triangles. Look at those numbers. They give us alpha, beta, and C. When I give you alpha and beta, you can change them to A, capital B. I don't really care. I just want you to be aware of that. With alpha and beta, all they're saying is if I have alpha and beta, A's across from alpha. B is across from beta. And then we have this C over here. Now mathematicians don't like cap C and lowercase c because they look the same. So instead of a cap C, we're going to use a gamma. It looks like a little Y. I'm not asking you to draw it. You can change it to a C. The reason why we have to know it is because there'll be some times where I say gamma equals 3 and C equals 44 or something. And you have to know that C is across from gamma. You can change the letters. I don't care. But I'm going to give you stuff that say like gamma equals 30 degrees and C equals. You need to know C is across from it. All right. That pretty much wraps it up for me. I am going to put the solution to this really quick. If you actually solve this, you'd come up with B is about 7.5. And A is about 3.6.